Section 6.5 deals with complex numbers, which that's what 4 plus 3i here is. This is the real number part. This is the imaginary number part. And together, they are a complex number. Now, complex numbers can be plotted onto a coordinate plane. The x-axis is your real number axis. The y-axis is the imaginary number part axis. So then 4 plus 3i would be located at 4 to the right and 3 up. Now, how does that relate to the things we've been doing so far? Well, if you draw this from there to there, that would be a vector 4, 3. If you make this, that would be a right triangle, where this would be 4, and that would be 3. And all of these things are related to each other. And so then, with a complex number, there is something called the absolute value. And the absolute value of any number, whether it's a complex number or even just a plain number like -6 or 10, the absolute value of -6 is 6, and the absolute value of 10 is 10. Because the absolute value is the distance from 0. Or in this case, with a complex number, the origin. And so in looking at this particular complex number, 4 plus 3i, the absolute value of 4 plus 3i is going to be 5 because it's a 3, 4, 5. Or you take 4 squared plus 3 squared and the square root of it. Now that relates to a 3, 4, 5 triangle, and as you recall from your last week of working with vectors, that would be the magnitude of this vector. Those are all the same thing, or related to the same thing. And so the absolute value of the complex number 4 plus 3i is 5. Now the other thing about that is if we have a circle with a center at the origin, that passes through that point 4, 3. The radius of that circle is 5. And since we have a radius then, and all of that other stuff can apply, we can take a complex number and convert it into trig form. And what that entails would be, if you have a complex number, the first thing you would need to find is r, the radius, or the absolute value. Which is also the radius, could be the magnitude, could be the hypotenuse of the triangle. Similarly related things. And then the other part of your trig form is cosine of theta plus I sine of theta. And to figure out theta, you would take the inverse tangent of the b part over the a part. And then you have to apply your rules and the knowledge of the circle and where it is and in which quadrant. Because if you're talking about a complex number over here in this quadrant, say right there, and you find that radius, this angle, when you actually calculate inverse tangent of the b over the a, you're going to only find this angle right here. Well, then you have to figure out that angle from there to there by taking 180 plus the angle that you found Or if you're dealing with something in this quadrant and it's like to this point, you're trying to find that angle, but when you do the inverse tangent, you're actually going to be given this angle. So then in this case, you would take 180 minus your angle to get to this angle that you need. So if we were looking at the example that we dealt with to start, 3 plus 4i, or no, 4 plus 3i, then we would be right 4 and up 3. And so then our complex number would be, the r is 5, and then we'd have cosine of, and in order to figure out this angle, we'd have theta equals inverse tangent of 3/4, which is approximately 36.9 degrees. And so then you would say cosine of 36.9 plus I sine 36.9. Or you can write it in radian form as well. So then if we have this example, -2 plus 2i, if we're going to graph that, 2 to the left and 2 up would be right there. So first off, r is going to equal 2 squared plus 2 squared and the square root of that, so the square root of 8. And then theta is going to equal the inverse tangent of 2 over -2, which is also the same as saying inverse tangent of -1. And the inverse tangent of a -1 is a -45 degrees. But that angle is actually this one right here, which that's not where we're at. We're in the second quadrant, so we're trying to find this angle right there. So we would take 180 minus 45 degrees to get 135 degrees. And so then the complex form of a -2 plus 2i, or the trig form, would be cosine 135 degrees plus I sine 135 degrees. Or you can say this is 3 pi over 4 in both instances. Same thing. Now moving on to some operations with complex numbers, multiplying. By your properties of math, you can change the order with the commutative property of multiplication to put these two things next to each other. And then if we multiply these things together, multiplying that and that would get you cosine theta 1, cosine theta 2. And then multiplying those two would get you plus I cosine theta 1 sine theta 2. Multiplying these two would be plus I sine theta 1 cosine theta 2. And then multiplying those two would be plus sine theta 1 sine theta 2, and then I squared. And now we know that I squared is a -1, so that turns this into a negative sine. Since these two both have i's in them, we're going to put those kind of next to each other and then put these two next to each other, and we are going to have cosine theta 1 cosine theta 2 minus sine theta 1 sine theta 2. And with the other two, you can factor out an I, and then you have cosine theta 1 sine theta 2 plus sine theta 1 cosine theta 2, like so. Still having R1 and R2 out here. Well then, this from here to there, if you look at your trig identity sheet, you will see in the sum and difference identities this particular formula, which is the cosine of theta 1 plus theta 2, and then plus I times, and this formula from there is going to be sine theta 1 plus theta 2. And there then would get you the trig form of two things multiplied together that are in trig form. So here's an example. You would have 2 times 5, which is 10, and then you would say cosine of pi over 3 plus 3 pi over 4 plus I sine pi over 3 plus 3 pi over 4. And so then 10 cosine, and let's see, we need a common denominator of 12, and that would be 4, and that would be 9, so 13 pi over 12 plus I sine 13 pi over 12. And there you have the trig form. Now, if you wanted to know what the complex number is for this, you would take this and put it into your calculator and then multiply it by 10, and that would get you the real number part. And then do the same thing, take sine of 13 pi over 12 times 10, and that would get you the imaginary number part of the complex number. And so with multiplication, you add the angles together. So then for division, applying your knowledge and skills about math, if you're going to divide, the rule or the theorem for that we had written, there's R1, R2. So then here when we're dividing, it would be R1 divided by R2. And then we had cosine theta 1 plus theta 2, and I plus I sine theta 1 plus theta 2. And so for division, it would be cosine of theta 1 minus theta 2 plus I sine theta 1 minus theta 2. And then just simplify it down. And so looking at this example here, you would have 5 divided by 2, and cosine of 3 pi over 4 minus pi over 2 plus I sine 3 pi over 4 minus pi over 2. And so 5/2 cosine, and this would have to be 2/4, so pi over 4 plus I sine pi over 4. These angles should always be the same thing. And that we will stop for today, and then tomorrow or the next lesson will be dealing with the rest of this section.